In this video, we are going to practice graphing sine and cosine functions, including changes in amplitude and phase shifts. Alright, so the amplitude is the A value right there. So the amplitude is 3. That's great. The period comes from the B value, which is right here. Oh yeah, you can't see it. The B value is 1. That means that the period must be 2 pi. Now the phase shift. When there's no visible B value, we can just look right here at the H value, and that's going to tell you the phase shift. And so the phase shift is going to be pi over 4, but it's going to be pi over 4 to the right. So it's the opposite of what you might think. If it's minus, it's to the right. If it is positive, it would be to the left. Now vertical shift would be a K value, alright, which would be right here. But since there is no K value, there is no vertical shift. So I'm just going to put none. Now that should be enough information for us to draw the graph. Let's see, let's start with the period. Since the period is 2 pi, I'm going to come over to here and write 2 pi. This is a convenient place to put the period. I'm leaving a little extra over here for any phase shifts, but okay, 2 pi. If I go halfway, that would be pi. If I go halfway again, that would be pi over 2. And in this position, that would be 3 pi over 2. Okay, now let's talk about the amplitude. Since the amplitude is 3 and there's no vertical shift, then I can just go ahead and mark my amplitude as my high and my low. Alright, up 3 down to negative 3. Now it might be good just to put a dotted line here to remind us where the high and low is. Okay, I think that's a good idea, don't you? Alright, remind me to cheat next time and make a horizontal line with a computer. Anyway, now let's ignore the phase shift for a moment. This is the sine function. So what does a sine function look like? Normally a sine function starts right at the midline, and it goes up to its highest point and it falls back to the midline, and then it goes down to its lowest point and back to the midline. So these 5 critical values show you what the sine function would look like if there was no phase shift. But there is a phase shift of right pi over 4. Okay, now pi over 4 happens to be half of pi over 2. So I'm going to use that coincidence to my advantage. Okay, so if I go right here, half of pi over 2 is pi over 4. So that shows me how big this phase shift is going to be. Alright, each point should shift this far to the right. So all I need to do then is put a mark halfway between all the way. Okay, because that's how far each one of these points will shift over. Now all of these need to be labeled. When it happens to be halfway in between, one way of doing it is to count. Count using the smallest unit. So this is 1 pi over 4. This is the same as 2 pi over 4. This will be 3 pi over 4. This is equivalent to 4 pi over 4. This will be 5 pi over 4. This is equivalent to 6 pi over 4. And this will be 7 pi over 4. This is equivalent to 8 pi over 4. And this will be 9 pi over 4. Now counting like that only works when it happens to be right in the middle, which does happen quite often, so it's a useful trick to have in your toolkit. So now let's go ahead and shift these points over. I'll use this marker this time. So this first point, if I move to the right pi over 4, it's going to land right here. And now I could really just do the rest of the sine function following the pattern, but I'm going to be looking at these green numbers instead of the blue numbers. So the sine function starts at the midline, it goes high, back to the midline, goes low, and then back to the midline. Or I could look at it as taking each one of these pink points and shifting them to the right half of a space. Alright, either way, my final answer should look like this. Okay, that got a little crazy in there. But you know what? Life is too short for me to do that over again. Alright, you know what if I just put a little frowny face right here? Alright, just own it. Acknowledge that it's a little janky and move on. Alright, that's it for number 14. Number 15. The amplitude, well, the A value is right here, yeah? See how it's invisible? That means the amplitude is 1. Amplitude is always positive, by the way. I always like to mention that over and over again. Alright, now as we move on to the period, we have to rethink what we're going to do with this equation. This equation is very, very misleading. Normally we just have an x, and here we have x over 3. Now here's what you need to understand. X over 3 is the same thing as having 1/3 x. That ink is too big. Stand by. Let's try that again. So I was saying x over 3 is the same thing as 1/3 x. Okay, so I have 1/3 x plus pi over 2. So this makes it a little bit more clear that this is one of those problems where we have a b value and a phase shift trying to happen. But in order to correctly determine the phase shift, we cannot just look at this. Pi over 2 is not the phase shift. We have to factor the 1/3 outside of parentheses. So if I take that 1/3 outside of parentheses like this, okay, to figure out what goes inside the parentheses, I need to divide by 1/3. Well, if I want to divide pi over 2 by 1/3, that's the same thing as having pi over 2 times 3. To divide by a fraction, you multiply by the reciprocal. And so what does that give you? Well, that's just going to be 3 pi over 2. Alright, this is like 3 over 1. So that'll be 3 pi over 2. Alright, so that's going to be the phase shift right here. Okay, so I could just put this cosine out here now. So really this is the function that we should be looking at. So if we want to know the period, we have to look at this b value right here. Okay, so the period is always 2 pi divided by the b value. So the period is going to be 2 pi divided by 1/3. And to divide by a fraction, you multiply by the reciprocal. So this will be 2 pi times 3. So therefore, the period is 6 pi. Okay, so that's really important. So the period is 6 pi. But also the phase shift. Again, the phase shift turns out to not be pi over 2. It is 3 pi over 2. And you must always mention the direction. So because this is positive, this must be 3 pi over 2 to the left. Okay, There is no vertical shift because nothing is being added or subtracted on the end. So for vertical shift, we're just going to go ahead and put none. Okay, that should be enough information for us to draw the graph. Let's start with the period. The period is 6 pi. Alright, it would be convenient to put the period right here. So if this is 6 pi, half of that's going to be 3 pi. Half of that is going to be 3 pi over 2. Okay, so I need to know what this is right here. Well, this third position is always triple the first position. Alright, so if I take 3 pi over 2 and I multiply that by 3, that's going to give me the third position. So this is going to be 9 pi over 2. Okay, that's bothering me, so I gotta erase this now. Stand by while I erase. God, which pen I'm using. Is this that big pen? No, I gotta erase some more. Ah, God. Ah, God.
Are you still recording?
Yeah, I'm still recording. You know what? Because I don't have time to stop the recorder like every time I make a mistake. I'll be here all day. That's my daughter Maya, by the way, questioning my recording skills. Yeah. Anything else you want to say on the video right now? Okay. So 6 pi. So now let's look at the amplitude. The amplitude is 1. So since there is no vertical shift, I can go ahead and do the amplitude like this, 1 and -1. Okay, I'm going to put a little line going across to represent the high point, and another dotted line going across to represent the low. Okay, now, what kind of function is this? This is a cosine function. So let's go ahead and graph the function as though there were no phase shift. Alright, the cosine function starts off high, and then it falls to the midline, and then it goes to its low, and then back to the midline, and then it goes high again. Okay, but there is a phase shift. The phase shift is 3 pi over 2 to the left. Okay, so we need to figure out exactly where that is. Now, it just so happens that 3 pi over 2 is one of the marks that I already have. So that tells me that this is how far I'm going to be shifting each one of these points. Alright, I'm going to be shifting each point this much. One full space. Wait, well, it's going to be to the left, though. But this is how far it's going to move. Okay, so I need to move these one full space to the left. So I am going to need one more value over here to the left, but if I'm moving to the left 3 pi over 2, then of course this will just be -3 pi over 2. Okay, so I'm just going to take these 5 values and move them to the left. Okay, so if I take this first point and move it to the left one full space, that's 3 pi over 2, then it's going to be here. Now what I could do is just do the pattern of cosine starting from this point. Okay, so I know that the cosine falls to the midline, and then it goes to its lowest point, and then back to the midline, and then goes to its highest point. Or I could have looked at it as moving each point to the left, one at a time. Okay, each pink point is moved to a blue point. Either way, the final answer is going to look like this. Alright, and that is it for problem number 15. Alright, I'm going to squeeze one more problem into this video. This one's going to be a little different because it does have the vertical shift on the end, and we have a fraction for the amplitude, so that's going to make this just a little bit different. Okay, so I have my a value right here. So that tells me that my amplitude is 0.25, which is also 1/4. So just keep that in mind. So I'm going to put 0.25 or 1/4. Okay, now the period is determined by the b value. The b value is right here. And as you can see, there's nothing there, so the b value is 1. And when the b value is 1, the period is the usual 2 pi. Now the phase shift. There is no phase shift. See how there's no parentheses? Compare this to the last problem. The parentheses are what show you that the pi over 2 is included in with the x. Inside the cosine function. If there were no parentheses, this pi over 2 would be outside of the function and it would be a vertical translation. So this has no parentheses showing. So that means it's sort of like this. And this plus 3 is outside, and so that means that this is the k value. This is a vertical shift that's going to be up 3. Alright, there is no phase shift. There's nothing being added or subtracted inside the parentheses. So phase shift, we will go ahead and say none. Okay, so the period was 2 pi. So let's go ahead and get that out of the way. So if this is going to be 2 pi, then right here would be pi. This would be pi over 2. And this would be 3 pi over 2. Okay, so that's pretty good, Now, we have to be careful with the amplitude because there is a vertical shift up 3. So the entire midline is going to change. So I'm going to need another color here. Maybe I'll just use this green. Okay, so the midline is going to move up 3. So here I go. 1, 2, 3. Alright, this is my new midline. Alright, it's hard for me to draw these horizontal lines, but I'm doing my best, you guys. I'm doing my best. Now, here's the trickiest part, you guys. I need some additional lines on here. I think I'll go back to the blue. I need some additional lines representing the amplitude. So the amplitude is going to be 1/4 above and 1/4 below this. Okay, so it's just going to be a little bit above and a little bit below. I think I'm just going to go ahead and try to put this dotted line a little bit above, even though this is really hard to do, and a little bit below. Okay, but these numbers need to be labeled, you guys. So the one on the upper side, if I take 3 and I add 0.25, of course that is going to be 3.25. Okay, that must be labeled. And if I go below, if I do 3 minus 0.25, that's going to be 2.75. So 2.75. All right, but those numbers must be indicated since they are not the values that are already on the graph. Like, notice, every other time we have labeled the numbers for the high and the low. We had 1 and -1. We had 3 and -3. It's no different now. Those numbers, the highs and lows, must be labeled. Okay, anyway, enough talk. This is a cosine function, so we can just go ahead and follow the pattern of the cosine function. Okay, so a cosine function starts off at its highest point, and then it falls to the midline, and then it goes to its lowest point, and then back to the midline, and then it ends at its highest point. Alright, so this little cosine function just goes a little bit above 3 and a little bit below 3. So it should look like this. Alright, it's a little bit hard to draw, but there you go. Alright, that's going to be the end for this video. I will see you on the next video.